This is the workshop component of the third lecture on probability theory, where I walked you through Daniel Levitin's fourfold tables, also known as contingency tables, and we walked through a case study, if you'll remember. And here I'm just going to walk you through it in Excel. This will be very brief. So if you remember, our question was, what was the probability of having bleuritis if you tested positive for it? And so the first thing we were told is that 1 in 10,000 people have it. So in our table here in Excel, first of all, you want to create a 2x2 table that shows in columns the test results, so those who tested positive and negative, and then in rows, disease status, presence of disease, yes or no, and then you also want to have the totals on the margins. So we're told first of all, we're told 1 in 10,000 people tested positive. So what does that mean? In the margin, one person had the disease out of our total of 10,000. The next thing that we're told is that the test is wrong 2% of the time. So how can the test be wrong? It can be wrong by having a false negative in this column or a false positive in this column. Now, 2% multiplied by 1 is equal to 0.02, and we're going to round up when we use this table. So there aren't going to be any false negatives because there only one person has the disease. However, we know that 2%, there are also going to be 2% of false positives. So how many false positives does that mean? Well, let's think. How many people don't have the disease? We know that 10,000 people have it. We know that our population size is 10,000 and one person has it. That means we know that 9,999 do not have the disease. So what is 2% of 9,999? Roughly, if we round, this is 200 people. So we'll enter 200 there for our false positives. So the next thing we can do to fill in the table is to compute the number of true positives. Well, we know if one person has the disease, 0 people tested negative for it, there must be one person who tested positive. So our true positive is equal to 1. As a side note, if we know the test is wrong 2% of the time means it's right 98% of the time. So 0.98 multiplied by 1, if we round up, equals 1. How many true negatives are there? Well, we know if there are 9,999 negatives and there are 200 false positives, there must be 9,799 true negatives, simply because of those who do not have the disease. If 200 tested positive, there must be 9,799 who tested negative. The last thing we want to do is we want to simply sum up these totals here in the table. So 1 plus 200 is 201. We add up 0 plus 9,799 equals 9,799. So we have our table completely filled in. So the next question is, our real question was, what is the probability of having bleuritis given that you tested positive? So this is equal to the number of true positives divided by the total number of true positives and false positives, which is this number right here, 201, and that gives us our probability of 0.004975, roughly half of 1%. So let's also calculate the sensitivity of the test. So if you'll recall, the sensitivity of the test is the number of those who tested positive divided by the total number of those who actually have the disease. So in this case, we're going to get the probability equal to 1, or 100%. The specificity of a test, if you'll recall, is the number of those who tested negative divided by the total number of those who do not have the disease. So that equals 0.97998. And that's it.